Hi guys, good morning. Welcome back to the new video. And oh god, like legit, the concept which is going to be applied is very easy and very standard. But how to reach? Bhai, ऐसा हो क्यों रहा है? Why it is being applied? How to think of that? That's super tricky in this problem. Although it's a medium problem, but I will put this problem in a medium hard category because to think, if you had solved the previous problems of that sort, it's easy, but not. Then to think that it's actually hard. So yeah, we will see. Ultimately, solution everyone knows. If you don't, for sure, it is very easy. Everyone has told that. But yeah, how to reach, how to think. Oh, it could have happened in that direction. Cool. Let's quickly jump into the problem statement without any bakwas. Cool. Simple, find k pairs with smallest sums. We are having two integer array called as nums1 and nums2 sorted in the ascending order. Cool. Nums1 and nums2 are sorted in the ascending order. See, it's marked in bold, and please, you have to make sure that you have to use the information provided in the question itself. Cool. It's already sorted in the ascending order, so please make sure that you use that information. If not, then we would have thought of something else. Cool. And an integer k. Okay, we have nums1, nums2 and is sorted in ascending order and an integer k. We define a pair u comma v with which consists one element from the first array, which means u is from the first array and v is from the second array. Cool. A pair u comma v is u from the first array and v from the second array. We have to return the k pairs u1 v1 u2 v2 up to uk vk, k such pairs with the smallest sums, that u1 plus v1 u2 plus v2, these like sums of these pairs. Ultimately, see, if you have n numbers in nums1, m numbers in nums2, in total you can have n into m pairs. Out of those, we have to give out k smallest pairs. For example, in this I had 3 numbers for nums1, 3 numbers for nums2. In total, I could have had 9 pairs. Out of those 9 pairs, I have to return 3 smallest pairs. So Aryan, what's the big deal in this? I'll just get those 9 pairs and just do a sorting on the basis of their sum and simply return the smallest k pairs. Are you sure you can do it? Let's see. You have n as 1e5. M also is 1e5. So basically you have 1e5 into 1e5 pairs. For sure, you can't even store these pairs, and neither you can have a runtime of, which means a time capacity of 1e5 into 1e5. For sure, you can't generate all the n into m pairs. That is for sure. But maybe we think of, okay, we can't generate all the pairs, but maybe we can generate, maybe we can have some starting n pairs or starting k pairs or something like that. Not sure if it is possible or not. Maybe if we can have something of, maybe I can have 1, 2, 3 pairs, then maybe I can increase my bounds as I go on moving forward. Let's see with this example itself. Okay, I have nums1, I have nums2 as the element 1, 7, 11, 1, 7, 11, and consider for the fact, okay, it could have had more elements also. Now, one thing we know, and one thing, please remember, it was sorted, right? So the minimum element is always in the beginning. For sure, if you want the sum as minimum, so both the number needs to be minimum. So one thing, from viewing the example itself, I could know, okay, one thing for sure, that 1, 2 will form the smallest pair for sure. Okay, 1, 2 will form the smallest pair. 1, 2 form the smallest pair. After 1, 2, what could be the next candidate for the smallest pairs? 1, 2 is gone. Okay, it was the first candidate, which we were sure, okay, it will be the smallest. What are the next coming candidates for the next smallest positions? 1, 2 is gone. Next come is 7 and a 4. So either it can be a 1, 4 or it can be a 7, 2. Ooh, these two are the next candidate for the smallest pairs. Okay, 7, 2 and also are 1, 4. So basically, we could see, okay, next ones are these. So out of this, someone would be minimum. So maybe it can happen, okay, as I keep on going forward, okay, let's say I choose, I know, okay, 1, 4 is the minimum. Then I will again have to increase the bounds of my range. Then again, new candidates will come from which I have to choose minimum. So one thing I for sure know, okay, I will have some pairs at a point of time with me. From those pairs, I have to choose the minimum pair in the shortest possible time. So maybe I can use something which means out of all the pairs, let's say all the candidates which I have, it can give me the smallest sum, minimum sum pair in least possible time. So getting the smallest thing in least possible time, getting the highest maximum thing in the least possible time, simple. A priority queue or a set, we want the least, which means we want the min heap. For sure, I can use a min heap to get, okay, out of all the candidates, what is the minimum sum pair I have? I can use a priority queue for that, for sure. But Aryan, that looks super confusing. Okay, like you just showed one candidate, you had 1, 2. After that, you showed 2 candidates being made. But then how this will go on further? I'm not able to visualize that. Cool, no worries. So initially we started like this, right? So let's imagine to imagine these pattern kind of problems now, make linear pairs. Don't go like complex, okay, like this, then this. No, go linear ways. Make a simple thing. Okay, make a simple linear pairs. I have 1 paired with 2, 7 paired with 2, 11 paired with 2. Now, it is a linear pair being made. Now, as soon as 1, 2 is gone, I know one thing for sure. What? Next upcoming will be 1, 4 only. As 1, 4 is gone, so next upcoming will be 1, 6 only. Let's say as 11, 2 is gone, right? So next upcoming will be 11, 4 only. So earlier it was cross, everything. So it was very hard for us to actually see, okay, what is the next pair coming up? But if we just make it down linearly, okay, just starting make all the pairs, because for sure we know that it will be 1, 2 will be minimum, and next will automatically come in if he wants to come in. So I just make my all the pairs. That's the reason. It's a mix of priority queue and finding the pattern out, and that pattern will actually reflect you in your old standard pattern which you have seen. I'll show that also. But yeah, I just made the pairs linearly, okay, because my only task is to choose the minimum out of them, and as soon as I choose the minimum, I will push in the next minimum, next candidate possible, right? I'll push in the next candidate possible, which is 1, 4. That's the reason I just made my entire pairs linearly. Okay, just in the copy pen, I just made everything linearly. How? Okay, if I had the pairs like this, I'll just make it small for you guys to have it visible. 1, 2, okay, done. 1, then okay, 7, 2, done. Then 11, 2, done. After this, and I'm just making the pairs linearly, like it should look okay, it should look linear. Then it comes as 1, 4, then 1, 6, then 7, 4, after 7, 2, and then 7, 6, 11, 4, 11, 6. So you will see, okay, I tried to make that, okay, all the pairs linearly. See, it is just representing the same input data, but such that, okay, it is structured, because I have to use the concept that these all are sorted also, right? So for sure, why not use that? You will see. For sure, these are sorted because 1, 7, 11 were sorted, and these are also sorted because 2, 4, 6 were also sorted. That's the reason entire thing is sorted for us. Now, as we have this, and see, it's just writing copy pen and visualizing and finding a pattern in the input data. How to reach to a pattern? We saw. For sure, we tried with the mix match. It didn't work out as my relationship, but yeah, it didn't work out, and then I went on to simply going on, okay, let's have it linear. Next time I will just push in the elements, which means when I say linear, what I will do is I will push on the starting k elements. Although it can be much more, but I just try to choose only the k pairs, starting k pairs, because for sure, I know my max size, bucket size, it can be k, because I'm concerned about only the k elements. So why to go beyond k? It is what we have also seen in the last problem itself, yesterday problems. Cool. Then what I did was I have this starting k pairs. Now I know the minimum out of all of them is this 1, 2 pair. And how to choose Rn minimum? Simply a priority queue. I will push in these starting elements, and these starting were easy to make because it was linear itself. 1, 2, 7, 1, 2, 7, 2, 11, 2, all these are linear. So it was very easy to push in. As I got this one, okay, it's a minimum one, and I got it from the priority queue very easily. I have got this. Next, what should come in? Next should come in the next element it should come in. Cool, because it is gone, because our priority queue size has reduced. It can go up to k, so let's keep it up to k. So I just simply pushed in this next incoming element. Now, did you find something similar? Have you ever seen this like this? It's simply merging k sorted list. If you had seen this problem earlier, if you had heard this problem earlier, it's nothing but, okay, you had k sorted list and you want to merge this. Okay, you just choose what is the minimum out of these k sorted list. Let's say it is a minimum. You take this and then you pushed your pointer to the next element of that particular linked list. Remember, that is simply a merge k sorted list kind of concept being applied here indirectly. You didn't do it, but as you were figuring out, you find, okay, yeah, it looks something like this. I will choose this minimum, then the next candidate would automatically come in because it is the next one, and it can actually be used to get the minimum. Now I have these three as the minimum, and you for sure know, because all things were sorted. You remember, right? All things were sorted. So for sure, this are the next candidates for the minimum. That's the reason. My main purpose was to bring in the candidates, and in the easy way, that's the reason I just bought it. Okay, write down linearly and then linearly. Oh, it was sorted. Now it is sorted. So for sure, I can choose the minimum out of these minimum candidates. Now, as it is also minimum, and how to choose minimum? Simply apply to you. It is gone. That's the reason. I know that, okay, I have to use priority queue, and also how to find the next element. See, because you choose the next element, you know it is minimum. Okay, it is gone. Then next element come in. But Aryan, in merge key sorted list, the list I had already been there. But in this problem, you told that you can't make the entire n into m kind of stuff. Then how would you know the next location of the next element? Although we could understand that, okay, it's a problem that we have to find the next element. What is the next incoming candidate which can be there? But how to know which candidate will be there? Simply again finding a pattern out. Let's say if I was at 1,2 and I need to go to, because 1,2 is gone, I need to go to 1,4. Is there any pattern in this? Yeah, 1 will always be there. So if I am going on to the next element, so I know the u comma v, u will be same as that of what I found as minimum. Okay, u I have found. Now what about v? It is 2, 4, 6 increasingly, right? And it should be increasing because it was nums2. So if I just clearly go and look on, it was the element of nums2, 2, 4, 6. If I had got a 2, the next element would for sure be a 4. The next would for sure be a 6, which means if I have got a 2, which is that index 0, next one will be at index 1, next one will be at index 2. So I also need to, okay, I know this too, but how to know that, okay, its index is 0? Because I know all the elements are not distinct. It can have duplicates, which means it can have 2 also. So I need to have the indexes also. That is how I know, okay, I will, although I am placing u comma v in my priority queue as a pair, I'll also keep a index of that. Why? Because I need to know, okay, what is the next element to find the pattern, because after 1,2, if it is gone, next one should come in. U I will easily find, it is the same as this u, but v, it will be the next index. For this, I need to know the index of this too. For this, I can't actually map it, so I have to store it. So I will store it the index here itself. I'll show the index. Okay, the index is actually 0, and it will be same for everyone, because for everyone the index is same. It's nothing but a same pattern which you are following. Now, as soon as I have got this index, I know the next index will be nothing but 1. Now the next index is 1. What is the nums of 2 at index 1? It is nothing but a 4. That is the reason I can easily get a 4. So basically, by this index, I'll also keep the track of index. As I go on to the next element, I know the index will be increased by 1. Index is increased by 1. I'll go back and say, okay, hey bro, nums2, please give me the value at index 1. He will give me the value 4. Okay, I will just make a 4 here. That is how I can make a new pair out. That's the reason I don't have to make the entire list. I find a pattern out which can bring me the next candidate for my particular row, and that's how you can get the next candidate. Cool. Now you know one thing. Okay, you will have a u, you will have a value, you will have an index. You can always, as this element goes in, You will just increment the index, you will get the index, and from the index itself, you can get the value from the nums2 itself. Cool. That was it, which means initially what I will do is a quick recap stuff, which I will just push in these elements in my priority, which is the starting candidates which I found. And also it's not important. If you had made it, you would have also tried for this particular stuff. It's just the starting candidates which would come in, and for sure we know that it would always come in. Next candidates would for sure be something like this, right? If you would ask for this, then simply what could have happened? The next it would have gone, next candidate would have been like this. So anyways, you know, it is sorted entirely, so you can have the starting candidates and make it linear, make it simple, make it easy. That's the reason I just found an easy pattern out of this problem. That's the reason you saw there were two patterns which you had to figure out from the problem itself. That's the reason it was a tricky problem. Cool. I choose the starting key elements, which means starting key elements. I just grabbed on the minimum out of all these key elements by simply using a priority queue, which is a min heap. I will define my custom min heap because min heap on the basis of the sum of these two elements, right? It's not a standard min heap. It will be a min heap on the basis of the sum of these two elements. So I will define a custom min heap, which will take you, okay, which will give me the min heap order on the basis of the sum of these elements. Cool. And that's all simple in this problem which you have to do. Just simply grab these elements, just bring out the minimum, remove it, push in the next element. If it is, then again keep on going until your k size is your k, which means your expected, because you have to get the k in the result, because the k minimum value is in the result. Until it is done, keep on going and keep on removing it, Now your new candidates are these. Keep on removing it. For sure, your k size is done. You are good to go. Simply looking at the code, it's very easy. Firstly, I defined my priority queue. Now, priority queue, it will be of vector by vector because I wanted a u, v, and the index also. Cool. So I will use a vector in that. Now, as I said that I will define a custom operator because I want a custom min heap. So if you had remember that if you want to make a standard min heap, so you used to write a priority underscore q, and then a int, and then a greater, and then a vector int, and then a greater int. Right? This like you used to write a min heap kind of stuff, but right now in this, my greater int won't work because I want a custom min heap on the basis of the sum of those vectors element. So I used a vector of vector, which means vector of this particular value, which is our input itself, and then a custom operator. Now this custom operator will be nothing but, as we do a simple sorting, okay, you have two arguments which are nothing but the vector itself. Now as you have vector, how we need to sort? On the basis of their sum. That, okay, if the sum I have, then whatsoever the minimum sum, please give me at the top. Now you will see, Aryan, the order is like this, but when we do a sorting, the order, we keep it like this only. Okay, if we want that, if the element, it should be less and it should come up, or it should come before, it should be like this way sorted. A, B, if A is less than B, so A will come first. But Aryan, here you write A is more than B. What will happen? Okay, it is a slight difference in how you write a custom operator for the priority queue and for the sorting. That okay, in simple sorting, what you write as A is less than B, then for sure it will be sorted in the ascending order, which means smaller will come first. When we say first, you will just get the values. Now in this, it just works at the top of the queue. Now for sure, for that we need to say, okay, if this sum is more than this sum, then for sure whatsoever this sum less. And for sure, to remember this concept, you can also remember that, okay, when you write a priority queue of min heap, then you use a greater int. Greater, it doesn't mean min, right? But still you write greater. That's the reason you can just remember that, okay, the sign is a bit different. It's of no use to actually explain this while using the code because we are solving a problem itself. But yeah, I have seen a few people forgetting this and it makes them a bit difficult. But here we also learn how to write the custom operator for priority queue itself. Cool. Now we have the priority queue which will actually sort and give us the minimum on the basis of what? Sum. Now as we have this base condition, although it's not required because the constraints are saying, okay, nums1 will not be empty, nums2 will not be empty, and k will not be 0, so it's not required at all. But still, if in interview it gives it, so you can just say, okay, if it is empty, it is empty. You can simply not get any of such pairs. Now, as I have gone, I will just push in linearly. I will just simply push in linearly those k, as I told you, So I will just push in those as I spoke, right? Where it is gone? Yeah, nums of I am pushing in with the nums2 of 0. So the same thing I did in, I push in my nums1 of I with nums2 of 0, and the index is for sure a 0 because it is the nums2 index. Now as the k elements, and see, it is the k elements being pushed in, so I just pushed in the starting k elements of nums1 paired with nums2 of 0. Now these k elements are pushed in. I will keep on going in my loop until I have exhausted my k pairs, because I wanted the minimum k pairs. Now out of this pq made, which have exactly k pairs right now, I will just firstly grab the minimum value pair, which means thus they have the sum as minimum, and I'll push in that result, because ultimately I have to give that result out. So I will push in my result, which is u and v pairs. Now when it is gone, firstly I have to make sure that I will go on to the next index. But if the existing index, and as you remember that, okay, right, it was the current index, it was the current index I. Now you go on to the next index, which is I plus 1. Now as you go on to I plus 1, what if the I plus 1, what if that I itself was nothing but the end of this? Or basically you can also say that, okay, I plus 1 is equals to the n, which is the length of this particular stuff, nums2 dot size. Or you can say, okay, I is actually equal to nums2 dot size minus 1, which means you can't go I plus 1, right? So I will just do a simple check, can I push in the next element or not? So I'll just do a current 2 is nothing but the index which we have been storing, right? So if that index is actually a nums2 dot size minus 1, which means I have exhausted that row, please you can't push in, you can't have another element, right? So okay, your row is exhausted, please continue whatsoever you have up till now. If it is not the case, I will simply go and push the same u. It is the same u which we had. The v will actually be changed on the basis of my existing index which we have will actually be stored in current 2. Current 2 will be the index. I'll do an index plus 1 and will find the corresponding value of nums2, and same I will just pass in the index plus 1 into the next argument. Cool. And then ultimately this loop will go on until it finds all the key elements, and then ultimately give the result. By this you can simply solve your priority queue. Cool. I hope, and see the complexity, as you know that, okay, you have this particular priority queue. In this you push in your key elements, and for sure at any point of time you have only key elements pushed in, so it will be k log k and space o of k, because priority queue will have only k elements at any point of time. Cool. I hope that you guys liked it. It was a very good problem of merge k sorted list, priority queue, min, heap, finding a pattern out of the problem itself. We know priority queue is being applied, but how? That's a big task in this. Cool. I hope that you guys liked it. See you in the next video. Bye bye.